Recording. All right, so we are going to refer to this book, Kubernetes in Action, second edition. If you buy it from Manning, you should also have a first edition. I'm a fan of first edition. I like that first edition a lot compared to the second edition, but there are some features I don't want to miss in second edition. All right, let's go through the content very, very briefly and see what is it that we want to talk about today and in general during this course. Introduction to Kubernetes, we've already done it, right? I mean, we've talked about how it originated in Google. We've talked about different parts of the control plane. We've done all that. So when you start reading through it, you should feel at home. Understanding containers, I think we have gone in pretty much in depth with Dockers and Docker container all the way up to Docker Compose, although we did not do Docker Compose a lot, but you all did an exercise with Docker Compose, if I'm not wrong. And you also heard from me there's something called as Docker Swarm, which is almost similar to what Kubernetes does, right? But we haven't gone into Docker Swarm. From a container perspective, you already know there is an image that is used to create a container, right? So there's a Docker image. Docker image is built from a Docker file, and you create a container from a Docker image, right? You know all of that. You know that there is ports for the containers, right? I mean, if you want to talk to the application running inside, it particularly speaks or listens on a specific port. So you already know about it. You know how to do port mapping. You know how to make a container dynamic by passing in environment variables. So all of that you know. So when you start reading through this, you should feel at home. Deploying your first application, I don't think so. We've deployed applications, so we will look at deploying our first application. Moving down, it's talking about Kubernetes API objects. So let's quickly go through it. Kubernetes API objects, they're going to talk about it. Workloads in pods, managing the pods lifecycle. All of this is pretty much brand new, so I'm going to skip them up very, very quickly because we will touch them. Okay, whatever is very important is where I'm going to wait and start talking about it. Attaching storage volumes to pods. I mean, we already know how to do volume mapping in containers, right? Almost similar concept. Okay, you can have your host volumes attached directly, but then there's a higher level abstractions what they've created when you don't want to explicitly map a host volume, which is called persistent volumes. Okay, and then to claim those persistent volume, there's a concept called persistent volume claim, which we are going to look at for sure. Configuration using config map secrets. Downward API, we may or we may not look at it, but you can always read about them. But we definitely are going to look at config map and secret. So since we are at config map and secret, let's briefly talk about it, what config maps and secrets are. We go to So I might not go word by word of what is there in the book, but I still want to go through it as much as possible so that when you start reading it, you'll feel at home. All right, so what do we have? Let's peel the onion, right? What is our least common denominator when we start with? We start with the image, right? A least common. I know Romana brought up last time, she said, can we start from scratch? Can we start from nothing? And I said, yes, we can, but very randomly I've seen anybody starts from there, okay? So you definitely start from an image. And this, okay, give me 1 second. I'll just be back. All right, so we have an image, and I would want you to just tell me as I'm moving down so that this is more of a test for you than anything else, okay? By default, where do we pull the image from? Okay. I will write that up, but just want to. So by default, okay, All of you have an account with hub.docker.com, if I'm not wrong, right?
Yes, Samir.
Good. So here, you specify from which image and which tag, right? If you do not specify the tag, if I just say image, will it work? Will it not work?
Download the latest.
Okay.
Latest.
The latest image by default, if you do not specify the tag. Is that a best practice to not specify the tag?
No.
Okay, it's not a best practice. So I'm going to make notes as I move forward. Okay, I have sent you a link of Docker best practices. If you've not read through it, please read through it. Very, very important. Okay. So never ever leave the tag out from here. There's one more thing that you should potentially do, which I'm going to show you now, is Docker installed over here. So let's go to yes. Anybody said something?
Hear me?
I can hear you very lightly. Romana, is that you?
Yeah. The question is, does Minikube comes with Docker installation?
No, it doesn't.
No?
Minikube.
Minikube, yeah.
Minikube will have, it will have Docker by default, yes, because it needs to have a container runtime.
Right. So why did it didn't pull up when you did Docker image?
I'm not running Minikube, right? I'll have to log in.
Yeah, you didn't. Yeah.
So yeah, we can do that too. Let's see if Minikube start. Bring this up. Okay, at the same time, let me log into. User ID password. Forgetting there's so many accounts that I'm working with. I don't remember this. Having trouble accessing. I have to get inside it, and then I will have Docker accessible, which I don't want to do it. So there has to be a container runtime inside, like the way we talked about, right? There'll be kubelet and container runtime, but it will not be accessible to me from sitting outside from the host. Were you able to get it working? No, right, Romana?
No, sir. Samir. I had some issue with the installation, so I couldn't complete it.
Let me try and go here. Okay. Okay, this is good. We don't have to worry about setting everything up. So I'm inside my EC2 instance. What I want to do is I want to pull Docker pull Nginx, let's say. I want to take you to documentation here. Here, which is talked about most of it. This one I want to show you is so if I say Docker image ls, right? This image is over here. What I want to do is there should be digest actually. This one doesn't have digest here. One second. Just anyway, if I get the link, I will send you, but the concept is pretty simple. The concept is when we create a Docker file, right? For example, if I do this, there's nothing here. So let's create Docker file, right? When I say from and when I say Nginx, I leave it here, cancel out. So by default, everybody knows it will bring in the latest. But what I want to do really is I want to do Docker images -- digest, and then you can grab if you have more. I do not have more. I just have one. Kidding me? Yes. Oh, digests. There you go. So you have this digest over here. So the best practice, right? I mean, let's see if I really want that. Let's look at this guy. So let's see it in action. Here. This is the format. Okay. So what you could do potentially is here, colon, latest. I mean, I know we should not be using latest, but we just downloaded latest. So let's put that one in here. And you can say add whatever. So this latest, I want to see what the image tag is. So I'm going to come back in there to add it. So now here's a test question for you. I want to know what is the image tag. So if I do this, the tag is latest, but I want to know actual tag. What is the number? How do I get it?
Inspect the image.
Yeah. So somewhere down here, there should be number. If you guys see it, just tell me. So I think it is this one here. 1216. That should be the one, because I don't see any other number around here. One two one six. I mean, that should be the one. But just to confirm, we can go to hub.docker.com, search for Nginx, and this is the official image. And if you see down here,
yeah,
that's the one, right? So it's always here. There are sometimes people who add it in labels. Okay, this guy do not have it. They just have maintainer, but somewhere it should be there. Okay, so 121.6. So let's get out from here. If I go back to Docker file, I can say instead of latest 1.21.6. Okay, what I wanted to show you from this over here, maybe what I'll do is I will send you this link, or you'll just read through it. It's a best practice. I don't know whether this guy has said it. Most Docker images are run as containers by invoking something along the line Docker run image tag. However, it's also possible and often necessary for security purposes to run by also specifying SHA:digest. But what does this actually do, and what security vectors does this actually provide? I think this is a good read for you guys. Even at your organization, Jyoti, they are not doing this. Okay, it's a very, very good practice.
Yes, Samir, this is first time
Exactly.
I'm looking at this.
It's a very good practice. Many a times, every book, everywhere where you read, they tell you have to always use a tag. Okay, which is good practice for sure, better than latest. But sometimes what could happen is you might be testing for the tag 1.2.6, and there might be a hacker who might modify that image if you're pulling it out from Docker Hub, especially. If you're keeping that image stored in your local, like how we are doing for JFrog, right? We are still safe because we know whatever image that we tested in our lower environment, that's the same image that is going to be promoted eventually to higher environment. But in general, it makes a lot of sense to generate a SHA and be solid sure that yes, I'm using this tag 1.2.21.6, but it is also the exact same image that I'm using. Anybody has any question here? What I mean by exact same image? I can explain that a little more if you do not understand.
Please elaborate it.
Yeah, what is from?
Clear, right? Or elaborate?
No, Samir.
No, Samir.
We are not sure about the SHA.
Sure. So now when you have a file, let's say, if you generate a SHA of that file, which is also called hash. Tell me another technology where you've heard this word hash, commit hash. Git, right? So what Git does is, based on the number of files that you commit at any given time, it takes all those files together and generates a commit hash or a SHA out of it. And that SHA is some number. So if there were 2 files, the SHA could be X1. If there are 3 files with some content, the SHA will be X2, so on and so forth. So what it means is SHA is a one-way hash, universal hash. Based on what data you have, if you generate a hash, next time if we have this exact same data, it's a guarantee that you'll always get X1. If even one thing changes in here, you'll never get x1, you'll get x2, something else basically. This x2 is not equals to this x2, okay? I'm just trying to say. So I'm talking in terms of functions. Are you getting what I'm saying now? At least the concept wise here. That same concept, oh, what happened? That same concept, let's apply it to Docker. You have your Docker image being created, right? Somebody has created this base image for you that you'll be using in your Docker file, in your image. Agreed? When you use this image, what I'm telling you is, tell me the image name and tell me the tag. But this image, you have not generated it. Somebody else has generated and put it over there, right? And we have seen it's Nginx official. Agreed up to here?
Yes.
What makes us think that when Nginx official has released this image number 1, they cannot delete that image and re-upload a new one called 1 with a file changed in it? Possible? You know you can do it, right? In your JFrog Artifactory, if you've uploaded an image with tag number 1, you can actually, if you're an admin, you can actually go delete it and recreate a brand new one.
Yes, that is possible.
Yeah.
If they uploaded by any chance, if they had a version 1, it had a SHA of X1, and they delete that one, they upload the same image again. Now the SHA is X2. In your image here, you are saying image : tag. It is still 1. Earlier you were using X1, now you use X2. What if this is being done by a hacker? Earlier it was all working fine. Now he has introduced the same tag, but the content has changed. Now, are you getting what I'm trying to get to?
Yes, Samir. So it is to uniquely identify a particular image along on top of image and tag number, add a
Yes.
SHA to it, and then
Correct.
we are sure that we are using the right file, right image.
Exactly. So the reason I brought this up is if in your organization, wherever you are, if you start using this kind of concept, people will understand that your attention is more for security. Okay, let's go back to where we were. Correct. So we saw that, and I just want to make sure that I'm able to build this. Okay.
Samir, how did you get this SHA number? Did you actually had to pull that image to get the SHA number, or
No,
any other way to do it?
Docker Hub registry.
So Docker images -- digests. So well, digest spelling mistake. Here, that's where it gives you, and it gives you digest only for the images that you've downloaded or pulled. So if you do not have that image pulled, it will not show you. So if
We would want to have that beforehand, right? Before pulling or downloading. So where would I get SHA number in that case?
you will have to pull the images, the from image that you need, you will have to pull it. So in normal case, what I will do, let me do this. Docker image from. Now do I have it?
No. Yeah.
I don't have it, right? So when I do Docker file, I'm not going to do this first. I'm going to just do from Nginx 1.21.6. That's where I'll start with. So if I do a Docker image build -t image : 1.0.0 dot. This is the time that it will pull. After it is full, I'll have to get the tag and then modify my Docker file. Okay. I'm not sure if Docker Hub gives you that digest already. It might. If it gives you, you can pick it up from there. I'm not sure. Okay. You'll have to check if it gives you a digest. The only way that I know of is I'll have to manually go get it. I don't know if they give a digest anywhere. I don't know whether it answers your question, but what I'm saying.
I was thinking, I would rather be sure about what image I'm pulling here at this point, right?
Mhm.
then after pulling, get the
No, that's
get
not the
shard.
concept, right, Romana? If you see the concept, the whole thing that we're trying to say is, where is this guy called? That's not the concept. The concept is I am pulling an image from Docker Hub. If I'm so scared of pulling anything from Docker Hub, I'm going to bake everything myself. So that is not the scare. The scare is not that I'm pulling an image. The scare is I have this image. I'm putting this in dev environment. I'm testing it and saying, yes, perfectly fine. I'm taking the same image. Definitely, I'm adding my layer on top of it. I'm putting it to test environment. I'm saying yes. But now when you're building and trying to push, so you might be building it multiple times, right? When you built it for dev, it worked. Then there was some time that you build again and then delivered to test, it worked. And test had multiple drops, let's say. You did 10 drops, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The 10th drop which you created, you got a wrong image. That's where the fear is. So the image that you tested all the while over here is not the same image that goes to prod eventually. That's the scare that we are trying to.
Yeah. This scenario I got it now.
So the scenario that you're trying to bring in is, even before pulling, I want to know what the tag is. That is not, I don't know what it will get us, Romana. That's the question. So I pull the image and then I get a tag and I stick it into my Docker file. So every single run, it will use that same tag, versus I already know what the tag is and I start it in the Docker file with that tag. How does that really help as per your understanding? I know it would have been great to get it, because then I would not have to go and manually change it. I understand that automation aspect of it, but from a security aspect, how does it help? It doesn't, right?
Yeah, it makes sense here in this context. I mean, where you're pulling the image, you're making sure you build it, you're making sure everything is fine, working fine, but you're ensuring that you are using the same exact image across all environments by.
Your voice is kind of breaking, but I kind of get what you're trying to say. Come on.
Okay. I don't know what's wrong with
let's
my.
move forward, because the intention is not to spend too much time on Docker, right? So let's not spend too much time on Docker. We have a lot to cover in Kubernetes. So let's connect the dots. So I said tag @SHA. This format, right? This format, SHA-256 : whatever that SHA is. Keeps losing. Okay, SHA-256 : the number. And how do you get that? You get it using Docker images. Okay, remember these images. It's not image, it's images. Just to clarify that, just want to make sure I'm not giving you wrong info. Let me try to build this. So Docker image prune, where are you, prune all. So I don't have any Docker images. I'm trying to go and build this again. Okay. Yeah, I just want to show you that the format really works, because otherwise you might think that the format doesn't work. So I was able to pull the image. If you see here, the Nginx image was pulled, but it has been tagged again as 100, which is my image. Okay. Docker image, I wanted to show you this. So Docker image --help and Docker images --help. You understand why I'm stressing on that S, right? Images, it's different. Okay. So Docker images --, digest. Okay. And this also there's a S. And then if you want to do grep, you can. If there are hundreds of images that you have over here, right? You can grab by Nginx, so it will give you only for Nginx. Okay. Is that all clear? No questions, right?
Yeah, clear, Samir.
Okay. Let's move forward. now you create an image, and what you could do in this image is, if you looked at Docker file, you look here, there should be an expose command. If you want to expose a specific port, okay, what your base image is not exposing. Most of the time, what the example that we've seen is we are exposing, we are not explicitly exposing anything. The base image itself is exposing port 80 or port 8080, correct? But if you want to explicitly expose a port, that's how you do it. And then when we are doing a port mapping, that's when we do -p of host, the host where you're running the Docker command, to the 80, which is exposed in the image. If you do not understand that, let me talk about it a little bit. When you create your container will have a port. Agreed?
Yes.
This container is going to be running in a Docker container, Docker engine. Your Docker engine is sitting on your machine. If you exec into this Docker container, you'll see that you're able to access the URL for that particular port, whatever that port is. But if you want to sit here and access it from your machine, you'll have to do a port mapping. So the port on your machine has to be mapped to the port of the container. We've talked about this earlier also. So this concept should be pretty clear to everyone. And that's where we do -p, this port, colon, y, this port. Any questions here? Any questions on this one?
No, Samir. Clear.
No. And you can map as many ports as you want, the example that they're showing over here. Okay, so let's move forward now. Thing is, if you understand this concept, right, you'll be able to read the book by yourself. If you do not understand this concept, you will not be able to. It will be very tough. Let's move here for a second. So we saw expose. There's a command and there's an entry point, which we talked about. Anybody remembers what a command does and what an entry point does?
Yes, Samir.
Okay, so entry point gives you, command is something that you can override
Yes.
when you're running, right?
With entry point, we can append.
Exactly. You can append something, a command to the entry point. You're right. In Kubernetes, they have a similar concept, which we will, I think they haven't talked about it yet, but we will be able to map it. If you remember this, that's great. Let's move. Shoot. I don't know why it keeps doing this. I lose the track from here. So we talked about ports for the container. We talked about command. We talked about entry point. We have not talked about volume, but let's talk about volumes a bit. So volume is when do we need volume for Docker container? We need a volume when we want to store something that's happening inside this Docker file on our host, or we want to have some files from a host to be injected inside the container. Agreed on that, right? So that when the container dies, the next container comes up, it can use what is stored on that volume. Everybody agrees to that?
Yes.
Okay, so that is the fundamental concept, which we will see with Kubernetes also. Then the next thing, what we have seen is we have seen environment variables, env, right? Basically, what I'm talking about is I'm not talking about env in Docker file. I'm talking about -e parameter that we pass. Everybody remembers that? -e, everybody remembers or don't remember? I don't know if this guy has -C. Doesn't look like. Anybody remembers environment variable or don't remember?
Samir, while creating the container in the Docker run command.
Docker run command, you can pass, right?
Yes.
Yes.
This one.
Yeah.
Okay, and I think we also saw n file, if I'm not wrong, when we were doing Docker. We've seen this -C, n file, and n. So let's go. The whole concept, the whole reason I started with all this was because of that. So now when we do -E, when we are running a Docker command, we are passing n file or we are passing env -E, right? Those two things. When we come to pod, which has a container running inside it, and if we want to give it configurability, in our world of Docker, -E was what was giving it configurability, right? I wanted to change the URL for production versus the URL for dev. I could have done it with -E. Okay. I could also do it with environment variable. If you remember, there was a concept which I showed you earlier. Something is not right. This is the container, and this is the pod, right? If I want to give this pod a behavior or dynamism, whatever you call it, right? There are two ways I can do it. Technically, there are three ways, but let's talk about configuration from a two perspective. One is I can use a config map. Or the second one, I can use secrets. What is the difference between config map and secrets? We will see it in action actually, but the config map is kept as plain text. Secret is base 64 encoded. Anybody knows what is base 64 encoded?
Yes, Samir, you have explained earlier.
Yeah, so it is encoded, not encrypted. Remember that. And that's the reason why it is not really secured, according to me. And we have seen this base 64 encoded even with VS Code to encode and decode that string, right? So you know how easy it is to encode and decode encoded string, but encrypted string is not as easy to decrypt. So if anybody asks you what is the difference between encoded and encrypted, you should know that encrypted is super strong as compared to encoded. Get my point?
Yes, Samir.
Yes, clear.
Okay. Yeah. So in my mind, if I have to ever build a secret, to me, encrypted is a secret. Encoded is not really a secret. And because it is not a secret, because you can, so let's do one thing. Let's move and create one so that you'll be able to better digest what I'm trying to say. At a high level, you know what a config map and a secret is, right? It's basically for configuration management, but config map is kept as plain text. Secret is kept as base 64 encoded. Okay, let's move to the next one. So config map, secrets, and then there are something called as download API. I really like this concept, but I have not seen anybody use it effectively anywhere yet. Moving to the next one, optimizing object using namespaces and labels. This is another good concept, and I want to give you a theoretical view of this. Can I grab this or maybe go to another one? I'll talk about labels a bit. I know you've seen labels earlier, right, in metadata. Why are labels important? I create a pod. What's inside the pod?
Containers.
There can be more than one container, one or more containers, right? There'll be containers inside it. Now, I told you every single, and we know it from container world, from Docker world, that every single Docker container that has a life will have an IP assigned to it, right? So you know that the pod also will have an IP assigned to it. Okay. Every single time, we haven't seen Docker networks yet, which we will eventually see, or I will give you indicators where you can go and see, is the whole idea about containers and pods is they can come to life and they can die at any given time. So if they can come to life and they can die at any given time, the least expected behavior from a pod is, or the application that are running inside the pod is, they should be stateless. Anybody knows what a stateless means?
Pods come up with a new name.
Okay. Anybody else
And
wants to give a try?
Where, I mean, there's no data storage across.
Correct. So what happens is, if you have same pod, multiple instances, none of the applications store the state inside here. They will not store the state inside. For example, in memory, they will not store a state. What does that mean? It means if first request comes to that application, and then that application does something, and the second request comes in, it will not remember what the first request was about. Every single request is a new request for it. It doesn't manage state. That's what stateless is. It doesn't manage state. Okay, so when we talk about pods, we will be talking about, most of the pods are all stateless. By default, they're all stateless. But there's this another one which is called stateful. Stateful, I'm really worried to talk about stateful right now, but just listen to me and then you can forget it, okay? Although we say stateless, I have talked about you being able to attach a persistent volume to it, right? So that means if this pod wants to store any data, that can always store data into the persistent volume, the PV. But that's the argument that you might bring forward and say, hey, there is a PV, so how is it stateless, right? I mean, you didn't bring it up, but I will bring it up. But what that means is this PV, this persistent volume which is there, it is not being shared. They have their own PVs. When they come up, they're having their own PV. So the next time when it comes up, you know what, I will keep this particular concept of stateful for next time, how a template is created along with PV. So next time when the pod comes up, it comes up with the exact same signature where it left out. I will bring it up in the following classes, because this is a pretty complex subject. I don't want to deviate you from the fundamentals. So let's leave this out for now. But you should just remember, it is not just stateless. There is also a concept called stateful, which we will look at. Okay, but let's get our fundamentals out first.
So Samir,
Stop it with making noise. Yeah, go ahead.
persistent volumes are only in context of stateful pods, right? Not stateless.
No. For stateless also you could have persistent volumes.
What's the need for that?
You might want to store some data onto it, right?
Related to configuration.
Related to configuration. Your config map also could be mounted on a persistent volume.
But config map is not attached to a pod, right? That's why it is kept separate, right? Isn't it?
What do you mean? We have
Is
not
it
seen
part
config map yet, so I will park that question.
Okay.
It is attached to a pod. That's the answer, short answer to you.
Okay.
Yeah, but we haven't seen it, so that's the reason why I don't want to answer that question right now. Okay. But what you should just know is there is nothing kept in memory. So this concept of memory and hard drive are two different concepts. Your persistent volume is hard drive. It's not memory.
Okay.
You getting my point or no?
Yes, Samir, please go on.
Yeah. All right. So let's move on. So it has an IP, is what I was telling you. This guy also has an IP. This guy also has an IP. So this concept of same pod scaled up to three pods. What is that concept called?
Replica?
Replica sets, yeah. Replicas, right? Now, if I have an application over here that needs to talk to one of these pods, it cannot be talking to this one and this one and this one, right? It's a replica of the exact same container, exact same pod. So what you would have in between over here is a service. The service will be mapping to this, and this guy has to just talk to the service because it has a DNS name to it. It gives the DNS name. We have seen in the control plane, there's a DNS service, correct? When we look at
Core DNS something. Core DNS.
I spell it wrong. Oh shit!
You have to do Minikube, Samir. Minikube.
No. I'm in EC2 instance. That's why.
Oh, okay.
Okay. Oh, get pods. It on like that. What was the command last time?
-A, uppercase A.
Okay, there you go. Thank you. Was that Saujanya?
Yes, Samir.
Yeah. So you see here DNS, core DNS service. That service is responsible for giving our service a DNS name. Okay. So there are several DNS services. The service that we have in Cube. Yeah. Is core DNS. Okay. Now, the whole reason I gave you this whole big picture was because I wanted to talk about labels. How does this service really know which pod to map to, right? There might be other pods in the ecosystem. How would it even know that it has to map? The way it knows is because this guy has set labels, and then when we create a service, we will specify what should be the labels on the pod that it will monitor. Okay, so that's the reason why labels are pretty important. This is one of the many examples which we will eventually see why labels are important. So when we create a pod, we define a label, let's say A, and when we create a service, we say there's a thing called match label. We'll specify this service what labels it should match to be able to discover the pods at runtime. Is this concept clear?
Samir, is this something similar to when we were creating Jenkins slave or worker nodes? We would specify a label, right? Something like that to group.
It's not exactly the same, but the concept is almost similar. So in the world of Jenkins, what we were doing was we were having many nodes, right? So let's say you create multiple nodes, and then you would group them up into labels.
Yep.
So the concept is almost the same, right? And so you would have this, and then let's say you'll have two separate. So this might be Windows, this might be Linux, and this might be Mac. So when Jenkins starts, if in the Jenkins file you said I want to run it on Windows, that's where one of this will be picked up, right? The reason I'm saying it's not exactly the same is because one of them would be picked up, right? Here we are talking more from a DNS perspective. So theoretically in your mind, if you have to think that the concept is almost the same, yes, it is. But practically it is not the exact same concept.
Okay.
Make sense? The reason I will tell you why it is not well, you know what, let's not get into it. But yes, the answer is the concept is almost the same. Any questions there?
No questions, Samir.
Let's move to the next part here. So labels and match labels, we have not really seen them, but you're able to get the foundation of what that could be, right? We create pods, we assign labels, when we create service, we specify match label. Service will have its own labels, but there will be a concept called match label where we will be able to tell which pods it has to match to.
One question, Samir.
Yeah, please go.
So in service configuration or something, we are specifying the label as to which group of pods to deal with or work with. Now we have n number of pods here, right? Even in a label, we'll have n number of pods, right? So is service going to act like a load balancer to decide where
Service is the load balancer, Rumana.
Service is the load balancer? Okay.
Yeah.
Okay.
All right, so let's move back here. So we were talking about namespaces and labels. Namespaces, I think you already know, I don't have to talk about. There's a cluster, and we said you could have namespaces separately so that pods could be assigned within the namespace. It's almost same concept, but fundamentally different. So this becomes an ecosystem for these pods. This becomes an ecosystem for this pod. So in OpenShift, this is called as projects. They are technically, you could have a pod that talks to another pod, which is in another namespace. OpenShift has made this a little more difficult, but there is a way for us to talk across namespaces also. Advanced concept, but if you ever read about it, you'll remember that I've talked about it over here. Okay. Let's move to the next one. Exposing pods with services. We talked about it. We will see it. Okay. Exposing service with ingress. This is where what Jyoti is asking about. We will be covering. Replicating pods with replica set. Managing pods with deployment. Deploying stateful workload with stateful sets. So this is where we'll talk about that stateful that I told you it's a little complex concept, right? Deploying specialized workload with daemon set, jobs, and cron jobs. So we will not go through the next part over here. This should pretty much cover up a lot of work that you will be doing in your day-to-day office work. Okay, you might be doing jobs, cron jobs, daemon set. Nobody does it, is what I know of right now, except for when I'm deploying the Splunk Connect. It actually deploys it at daemon set, but you're still not creating it. Okay. But just for the sake of it, we'll scroll through a little bit. Okay, Jyoti, everything that you're doing with OpenShift should be all revolving around here. And you would not even be doing this hardcore. The reason is you're using Helm. You're not directly interacting with OpenShift, correct?
Yes.
Right, let's move down. Let's quickly see what else we have. I will tell you what is it that we will not be able to cover. Understanding Kubernetes APIs in detail, understanding the control plane components, we've already done this. Understanding cluster node components, we are not going to cover it, but you can read it. Understand the internal operations of Kubernetes controller. This is a very good topic. We've briefly talked about it, but you should read this topic for sure. Number 20. Deploying high, yeah. Anybody, any question?
Yeah, it's me, Romana. Is OpenShift similar to K8's Kubernetes?
Sorry, what was that, Romana?
Is OpenShift similar to Kubernetes?
OpenShift is built on top of Kubernetes.
Built on, okay. An advanced version of Kubernetes?
Well, I would not call it advanced. Everybody's moving away from OpenShift now. They have just added a thin wrapper on top of it. Everything under the hood is all Kubernetes. Last time I actually said the differences briefly. They have added HA proxy, and they have introduced ingress and created a concept called routes, which Kubernetes doesn't have it. Kubernetes tells you, you install your own ingress controller and you define your own ingress as configuration. OpenShift has actually created it as a service.
Okay.
Okay, there are some more things like that. OpenShift has a concept of project versus namespaces, which is not new, which is exact same thing, just renamed. They have a concept of user management, which Kubernetes doesn't really give you out of the box. So there's nothing called as kubectl get users. There's nothing called like that. But I think OC get users should give you something in return.
Okay. Okay.
Yeah, we've talked about it, Rumana. I think you've missed it. OpenShift and Kubernetes. But let's move forward. Deploying highly available cluster, no, we're not going to look at it. Managing the computing resources available to pods, yes, we will look at this. Advanced scheduling using affinity and anti-affinity. We can talk about it, but we may not practically do this. I will tell you what affinity and anti-affinity is. If you ever have to talk about this, or you want to go ahead and read these topics, you can. Automatic scaling using horizontal pod autoscaler, HPA. We will not actually do it, but we will talk about the concept of what HPA is. But if I have to quickly tell you what HPA is and what affinity and anti-affinity is, I will quickly tell you. So affinity and anti-affinity basically can be at node level and pod level, okay? So what it means is, if I create a pod, if I don't want that pod to go to the same node, I would create an anti-affinity. Or if I want a pod that goes to the same node, it will be affinity. So I have an affinity towards you, I have an anti-affinity towards you. When I say affinity, that means I would love to be closer to you. If I say anti-affinity, it means I would want to be away from you. That's what the concept is all about, okay? So when they have made this concept a little complicated in terms of how you use it. And I have not seen anybody really using it. In your organization also, they're not using it. It's a good concept to use, but they're not using it. Horizontal pod scaler is, if I want scale out and scale up are two different things. Have we talked about scale out and scale up before?
No.
So if I consider, it's troubling me today. If I do this, if I say this is in, this is out, this is down, this is up. Okay, scale out is moving from here to here. Scale up is moving from here to here. I know this doesn't make sense to you, but now let's talk about in a practical way. So if I have a system with 1 GB of RAM with 1 CPU, and I'm not talking about hard drive for now, let's leave it out. So we're just talking about memory and processing power. This is what I have. When I say scale up, what it means is I want to move up from here to the next level. What does that mean? I'm going to bump this up. So from 1 GB, I will make it to 2 GB. And 1 CPU, I'll make it to 2 CPU, let's say. These numbers are just imaginary numbers, okay? It can even be 20 GB RAM and 20 CPUs, okay? But what I'm doing is I'm taking the same machine and I'm installing more power to it. Understand? That's what scale up is. When I say scale out, what it means is I will create a duplicate of this guy. I'll create duplicates of it. So each one is 1 GB, 1 GB, 1 GB RAM, 1 CPU, 1 CPU, 1 CPU. Okay. So what I'm doing is scaling out, scale up, scale out. Getting the concept?
This is HP something.
Vertical and horizontal.
Yeah. So vertical and horizontal. So horizontal pod scaling. Where was that? HPA. Yeah. Autoscaler. So you can so basically it is similar to replica set, right? But replica set, what it does, it says I want a hard 3 instances. in your organization, Jyoti, they're using replica sets. The problem with replica sets is this resource, whatever is assigned to that resource, is being idle there even if they are not used. Okay, versus autoscaler. This is we have seen this in AWS actually, and Saujanya has done a test around it, right? You can start with minimum 1, and you can define a rule that I want to go to maximum 3 and scale out of 1. So first it will be 1, then 1 will be added, and then third will be added. Added based on what? Added based on
load.
Memory, added based on CPU. Mostly the time that I was reading through Kubernetes, it had provided something for CPU, and for memory it was a test. Maybe by now it is not a test anymore. Okay, but there's memory and there's CPU. Then there should be another one, according to me, which I didn't see it earlier. I'll be surprised if it's still not there. It should be based on traffic. I should be able to define traffic of X load. If it increases by whatever that factor is, I want a new pod to be created. You know what I'm saying, right? So there's one pod sitting over here. It can take 100 requests at any given time. If that request goes up by 1, I want a new one to start coming up so that the load could get distributed.
That should be the main criteria, right, Samir? Load.
It is not. It is not at the moment. And that's the reason why in the current organization that I was working in earlier, with wherever Jyoti is, they were not able to successfully do it. The reason was the load was coming up higher, but the CPU was still less. So we couldn't use the CPU threshold to say, go ahead and create a new one, right? The memory consumption was also less. So the whole bottleneck was how much of load can the HTTP server really take? So what I had suggested was to create a t-shirt size to define where, how many concurrent connection can your JBoss instance really take, or a Tomcat instance really take. We can configure that, and we have configured it during performance tuning, but we could never get to a point where when the load comes up, the CPU spikes up or memory spikes up so that we can do auto scaling. It wasn't there. So we would have to write some customization around to define the traffic. Okay, so I will leave that out for you for now. So we will see auto scaling, but I would say I haven't seen anybody successfully used it in AWS. Yes, but even in AWS, imagine, right? You have your EC2 instance, you have your application deployed over here. The application is just consuming way less CPU than you have over there. You cannot really auto scale, but the amount of traffic that is coming in, the application is not able to serve those traffic. So if there are 100 calls coming in, it is just serving 50, and the 50 are getting dropped. But CPU is not spiking up for that. So this is not our area right now. That's a performance area, but I just want you to know that fundamental. Okay, let's move to the next one.
Samir.
Yeah.
Sorry, if you go back to the diagram, for the in and out, what is the criteria for scaling up the resources, capacity of the resources?
Scaling up or scaling out?
Sorry, up and down.
Scaling up is basically traditional way, right? You have your server sitting out over there, and the server. I'll give you a real example. I was working with an organization, a very small organization. So they say during the Eid, I'm going to get a lot of load. Proactively, they say, okay, we were on 6 CPU. I want it to be bumped to 12 CPUs now, because they know the load is going to be increasing. So it's more of a manual. And what we did, we just increased the amount of resource on the CPU. Is there a question there, Romana? I think it should be pretty clear there, right?
Yeah,
What is
I
it?
just wanted to make sure it's not happening dynamically, right?
No, it
You
is
know
not.
ahead in time, you know ahead in time, key, this is the time where I'm going to expect the peak or more load, and then you bump it up in advance to.
Correct.
Okay.
Scale up is never automatic.
Okay, got it, Sam. Thank you.
Right, let's move down. Securing API using role-based access control. This is a good one. This is more from a security perspective. How you can control the access. So we will try and cover this access control a bit.
Securing API, is that API server or
Securing
something
the
else?
API, not
The
the API
API
server.
server in the control plane that you talked about is
Not the
it
API
that one?
server. APIs which are served by the API server. Who can access? Who can get access into your cluster? That's the whole thing. Role-based access control.
Okay.
Protecting cluster node, I don't think so. We will be able to cover that. Securing network communication using network policies. Now, upgrading, backing up, and restoring Kubernetes cluster. This is a very, very important topic. I think I told you number 20. If somebody is making a note, please make a note. Number 20 is a very important concept. Number 28 is a very important concept. Okay. You would not be, the whole reason I will not cover this, I will not go into the details of it, is because nobody will expect you to do this into your current organization. Okay. But it is always very important to know. Okay, let me ask this question as a test. For Kubernetes, where is all the state of Kubernetes kept?
HCD.
It is HCD. So when we talk about backing up, right, we're technically talking about backing up HCDs, and there's one more place where you would store application data.
Application data.
Persistent volumes.
Right. Yes.
Right. Those are the two important things that you would want to back up. Okay. So backup and restore is a very important concept. Okay. So number 20 and number 28, please remember that. Adding centralized logging, metric, alerting, and tracing, a very important concept too, but as compared to 20 and 28, comparatively lower priority is what I would say, but it's always good to see how much of data, how much of CPU and how much of memory your pod is really taking, so that you can gauge it and fine tune those resources, which we talked about earlier, right? We will cover it based on these metrics. And you want to have alerting and logging. So whatever logs are being stored, there's another important concept which we didn't talk about. Let's quickly talk about it. Is I have a pod running here, a container running here. I said container can store something into the persistent volume. Okay. Or the pod can store something in the persistent volume. One very important thing you should take care of is when you create the containers and you put your application inside the container, and this container is put inside the pod, this application which is writing, you should always talk to the developer and make sure they are not writing logs to files. Ever write anything within the container to files, especially the logs. Application data, if you really have to store it, you have no choice. But even the application data, you might want to store it into a database or a fast cache, like Redis. You want to avoid writing anything to file system as much as possible, because that will only lead you to problems. And why am I saying logs especially? Logs in container should always be streamed to console. Because if you stream it to console, we can deploy point D forwarders or Splunk forwarders, which will read the data that is being sent to console and send it out to their dashboards. Jyoti, you've heard of Splunk, right, being used?
Yes, Samir.
So what we do inside this Kubernetes cluster is we deploy another pod called Splunk Connect, which is responsible to pull data from the logs that you send to console and push it out. There are more components in here, okay? It doesn't go to dashboard directly. There's a component called indexer, and they have their own DB where it is stored, and then dashboards basically reads from those DB. But I'm not really covering it because we're not talking about Splunk. The concept that I'm trying to really tell you is always make sure developers do not write, or their log4j configuration, if it's Java, they do not have appenders that write to file. The appenders should only write to console. Any questions here? No, right? Let's move forward.
Samir, if you have to set up Prometheus and those kind of dashboards, it would be on each of these nodes?
What do you mean?
Like if you have to pull metrics of each of these nodes, right?
These are not nodes, right, Romana? These are pods.
Sorry, yes, pods.
So let me tell you that. In the world of Kubernetes, everything is namespaced, right? So this is cluster. This cluster under the hood has nodes. So when you said node, I was thinking you're talking about this node, and I was like, what are you talking about? These are nodes. These are actual hardware with CPU, memory, hard drive. Okay, so these are nodes. These are namespaces. Inside the namespaces, you have pods. Inside pod, you know what is there. They can be containers. Okay. Now, when you want to get the metric or scrape some data from here, what you could do is inside this namespace, you could deploy your Prometheus pod. Everything will be pods, right? This is Prometheus. It will basically get data from all of them. So there's a Kubernetes scraping tech, like how you did Jenkins, right? Scraping. If you read about Prometheus, there will be Kubernetes scraping available. And inside each and every pod, like how we had done for Jenkins, we had installed a Prometheus plugin. Remember that? Correct. By which it will give me a matrix endpoint.
Yes.
Do you remember?
Yes, Samir.
Similarly,
yes.
We will have to make sure that we deploy the Prometheus agent so that it exposes the endpoint that this guy P over here could pull the data from. And now whatever data is pulled, that data, you could have a Grafana that actually goes and creates charts out of it. Now, to answer your question specifically, this Prometheus, in the world where Jyoti is, this Prometheus is installed in each and every namespaces where it's required. But technically, what could be done is you could have a separate namespace called Prometheus, and Prometheus could be sitting over here. And as I told you, they can talk to whichever namespaces you want.
Got it.
To me, this would have been a better way to do it. But since OpenShift has an issue with namespaces talking to each other, and now they have to go against the security to enable that, they rather prefer to have Prometheus sitting in each and every namespace so that it's isolated only to that namespace. Did I answer your question?
Yes, Samir. Yes, thank you.
Let's move to the next one. I don't know why did I speak comparatively more than I speak usually today? I'm kidding. My throat started paining actually. Maybe because, well, I don't know. I was outside actually last night. We came back late. I came back around 12:30. I was awake until 1:30, trying to prepare for you guys. Maybe because of that, I'm not sure. All right, let's move forward. So are you guys making note? This one?
20 and 28.
This one and 29. Okay, let's move down. Oh, we're almost done. Cool. Kubernetes development best practices. No, we're not going to look at it. Extended Kubernetes with custom resource definition. We are not going to look at it, but this is a very important concept, operators. Okay. If you have to do anything serious in the world of Kubernetes, this chapter you have to read, and you have to try and identify that any books or blogs or videos which will give you more information about how to write your own resource definitions. Okay. So we will start from resource definition today. I know we just have little time. I hope nobody thinks we wasted time by going through this, what we are going to cover. Because the whole reason I wanted to do this is because I want you to read this book. Okay, so let's start with custom resource definition for a second, because that's a very good concept. And I'm not going to talk in details, but I will tell you what the concept is. Saujanya, is this overwhelming? Too much of data?
No, Samir, not today, but last week I felt. But after going through that, yeah, now fine.
You're feeling comfortable?
Yes.
Good. Good. Yeah, you wouldn't believe how hard it is for me to simplify this and put it in a way that it doesn't overwhelm, because there's so much to be overwhelmed about. It's not difficult, it's just too much. Okay, so do you remember we talked about it's not right.
Did anyone get the kubectl installed? I had some issues.
It troubled me a lot, Rumana. Finally, I got it.
Okay.
What was it? What issues were you getting, Saujanya?
That was for me, Samir, Rumana.
No, but Saujanya also said, right? She was able
Yeah,
to get
some
it. But...
BIOS update, something like that.
Oh, wait, we have to enable the hypervisor on your BIOS. If
Yeah,
it's not
I
enabled.
have the virtualization turned on, Samir.
Then what error are you getting into?
No, it just times out. I didn't spend much time, but it took way long. I mean, I tried that administration, running it through administration way as well, but
Are you sure you're specifying the driver? Have you defined the configuration or you're specifying driver as VirtualBox?
yes. I followed the exact same steps from
There is,
video.
when you're doing that, right, there are several other parameters. There's a parameter to define your memory. So try doing that. Give it some more memory.
Okay.
If your system doesn't have enough memory left, then your kubectl will take a long time and it will not even start sometimes.
Okay, got it.
Yeah.
I think going to the user profile and picking that configuration file that you showed and updating memory over there, that should do that. That should help me.
Hopefully, yes, because I've seen there are issues around with memory sometimes. So take a look at it. You should be able to figure it out. Okay, I wanted to talk about controllers.
Rumana, I just texted one command. I tried that.
Yeah, minikube is fine, Saujanya, for me.
Oh,
kubectl is kubectl is the issue.
Oh, okay.
Wait, you got minikube installed, you're saying?
Yeah, minikube is fine. I mean,
kubectl should not challenge you at all. All this memory stuff I was talking about was minikube. kubectl is a very small binary. You can just download and put it up into your folder. Actually, you don't have to install it even.
now it's coming up. It was timing out last night.
Yeah,
but
kubectl is nothing. kubectl is just a small binary.
It will come again, Rumana. Without restart, it didn't work for me. If we restart, it worked.
What you had to restart, Saujanya?
Machine.
Yeah, restart machine.
I didn't restart my machine since last night, but it's coming up now.
It will come up. If you have problem, just ping me. I'll help you out with that, Kumana. Let's
fine,
we just have how many? Just few minutes. Let's cover this up a little bit. So controllers, right? I told you there's something called as pod controller. There's a replica set controller. there is there are several controllers. Each and every topic that we will talk about, daemon set controller, stateful set controller, XYZ controller, there are so many controllers. Okay, each one of them has a very specific role to do. Okay, the chapter number 20 that I've told you, please do read it today if possible, so that tomorrow are you guys available or you're not available?
I'm available.
Available, right? So
Yes,
please read chapter number 20. And the whole reason I'm talking about it now is so that it makes a little easier for you. When a person, when Romana is sitting over here, Romana, that's you, or Rome, let's say, whoever it is, okay? And she's using the kubectl command. That kubectl command is going to whom?
API?
Kube API server, right? API server. This API server talks to whom? HCD, right? And what is Romana going to send? We have not looked at it yet, but just trust me, that is what we will do. Romana, if she wants to create a pod, she's going to create a simple file, which is called manifest. What manifest? K8s manifest. Okay, which well, we have seen it, and I had also asked you to go through that manifest. Remember, API version, kind, pod, spec,
metadata,
and metadata, right? I've asked you to do that. So that is the spec that Romana is going to take, and Romana is going to fire a command called kubectl apply -f, and then that manifest. So that will create the pod. How does it create a pod? Is what we should be asking ourselves, right? That's the important one. So when the manifest is received by K8s, K8s takes it and puts it up into HCD.
even before the pod creation or after pod creation?
No. Kube API server is not responsible to create the pod. The only responsibility is it will put in HCD the manifest. Since it is put into in HCD, what was the kind? The kind was pod, right? These guys, each of the controllers listens to the change. Okay, as soon as there's a new one created, which is pod, which among this should get activated? Yes.
Pod controller?
Yes. Okay. So pod controller is going to get activated. Pod controller here. Pod controller will talk to scheduler and say, tell me the node where this can be scheduled. Tell me the node where it can be scheduled. So scheduler is going to talk to kubelet, right? Kubelet will, there are several kubelet basically. It will talk to each of the nodes, and it will identify if that particular node has space and bandwidth to take up that pod based on the resources that are defined in that pod. So we haven't talked about resources, but during the topic, you remember I told you, right? We'll look at resources. A pod can have resources specified as part of the spec. So based on those resources, it will identify it can go here. If it can go here, it will basically go and stick up the node in the pod spec. Okay, you can even look at it from a different perspective. Even before pod controller can take it, this node information will be added to the spec. The pod controller is responsible to say, yes, go ahead, kubelet, go, here's a pod spec, please go create it. And this information might be, again, it will store it up into HCD. KAS will take it and give it to this guy, the kubelet, because that's what we saw, right? KAS talks to HCD, KAS talks to scheduler, KAS talks to kubelet. Everybody else was sitting over here, controllers and everyone else, basically get activated by the change in HCD. The only job that they do is they say, yes, all the information looks good. I have done the validation. It is ready to be sent to kubelet. That is the only job that pod controller or any controller will do. Okay. It will eventually be sent to kubelet. Kubelet will give it to container runtime, and your pod will get created. So the important piece is each of the controllers have a very definite work to do. Okay. So now, why did I say custom resource definition and I came here? You can create your own custom resource definition, like how pod controller, pod is a resource, right? Like kind pod. You can create your own resources, and that's what is called custom resource definition, or CRD. Okay. So when you look at this, the last topic, that's where you'll have to remember that I did talk about custom resources. Okay, let's move down quickly, and I'm going to scroll through so that we can look at something in action. I'm not going to go through all of this. You can go through it. This is all fundamentals. Let's move to.
Are there any custom resources you can think of, Samir, other than pod?
Several. Prometheus is a custom resource. Istio is a custom resource. Everything else that you will install apart from which is given out of the box by Kubernetes is custom resource.
Got it. I mean, although it is out of topic, back in that diagram, I had a question about scheduler. If it's okay to go ahead.
No, don't ask right now, Romana, because that question will get answered. I know what you're trying to ask.
Okay.
Because there's a whole big topic that will talk only about schedulers.
Okay.
Because this is where the API server talks to kubelet, kubelet talks to container runtime, and then the pods get created, right? And then there's a kube proxy, which is responsible for the service DNA service across the nodes, basically. That's where kube proxy will be responsible. Moving down. I think this is a good one. Manifest containing 2 deployments and 2 services sent to the API. For each deployment object, a controller creates additional objects that represent individual application instances. That's what we talked about. Each controller has its own role to play. So there were 2 replica sets, 3 whatever, 2 deployment, 3 replica sets, so on and so forth, right? It basically created that. The scheduler assigns a node to each instance. So each one of them that they created, there will be node that will be assigned. So scheduler will talk to kubelets to identify, or whatever algorithm it uses to identify which node is available to deploy it. The kubelet on the node instructs the container runtime to run the instances, whatever instances you created. The kube proxy creates a load balancer for each service. So we already talked about it. That's the whole flow, basically, from the time you submit your manifest to the time it is created and managed by the container runtime. You can read through it a little bit to understand what it is doing, but I've told you what it does. Introducing Kubernetes into your organization, I don't want to worry about all this. Let's move here. Understanding containers. This also, I think we don't need to worry about, because we already talked about what Docker is at length. If you want, you can go through it. So from image registries, you have several apps. You create your own container from there, and then you have to run it in the container runtime, or running control container. Basically, we already know it, right? From Docker file, how it pulls images and how you create a runtime or container. We've already talked about it. This, Docker build command. I'm not going to go through it. So this whole topic you already know. You should just be able to glance through it and you'll understand. Okay, don't spend too much time on it. This is where we will have to spend some time. Basically, deploying KIADA, the Kubernetes in Action Demo application, right? Kubernetes in Action Demo application. I don't want to spend time writing and building the containers ourselves. We will use what they give us. So here's where they are actually showing how the application is going to be, so on and so forth. And you have your browser talks to web. Then there is a code service and there's a quiz service. And each one of them have their own DB, code DB and quiz DB. That's the architecture of the application. Let's move forward and please do spend some time going through this page, okay? Page number 36, if you can just note it down of what the application is, because even in your real world, before you can go and deploy your application, create Docker images from it, think about how it is going to be deployed, how it will talk to each other. You need to know what the application does. So the questions like, is it logging to a file, you know, the application, all those questions should come up during this discovery phase of the application. So please do spend time on page number 36. Let's move down. Here's where they're talking about, you know, how it will call the web and how web will talk to those two services, and those two services have a database backing. Building the application. So it's node application, basically, what they are saying. To package your app into an image, you need to create file called Docker file, which contains a list of instructions that Docker performs when building the image. We probably may or may not have to create it because there should be Docker images available. So let's move forward. So they're building the latest. Here, they're creating the Docker image from the Docker file. Again, just to reiterate, all of this, what I'm going through, you know why I'm going quickly, right? Because you already know all this. Everybody understands that, right?
Yes, Samir.
Yes, Samir.
Running the container, you want to run it locally like this. They have given it, there's a port 8080 on the host. It's 1234. You're mapping it to the container port 8080. It's creating as a daemon. It's trying to say, and the image name is Kiada, latest. Then you're able to access it using localhost, the browser, or you can even curl. Docker ps command, you know. Docker inspect command, you know. Distributing the containers, you know. You can send it to Docker Hub, or you can even send it to JFrog, you know that. The image to Docker Hub. Please do read through this a little bit because it will refresh your Docker commands. You don't want to worry about all this. Let's move to something Kubernetes so that we do something. Okay, deploying your first application. This is where we will start with tomorrow. Okay. I would really appreciate if you can glance through the exact same way I've gone through. You know, if you're able to run Docker commands, whatever they are talking about, create the Docker file, Docker image, so on and so forth, push it to your Docker Hub account. I would really appreciate if you can do that, because we will start over here and we will deploy the first application. So let's see. Whatever we covered so far today, is everybody comfortable with it?
Yes, Samir. Yes, Samir.
So starting, right, all this is all about installing the cluster, which we've already done. So don't worry about any of this. We will use Minikube to start with, and later we will do it on EKS. So don't worry about G-Cloud, creating a cluster on Amazon. Maybe this is something that you might want to check, because creating a cluster is in Amazon Elastic Kubernetes service. This is page number 66. Again, you don't have to read this, but just note it down for your reference, because if I'm not around and you have to read this book and you need to know what is the important points, that's the pointers that I'm giving you. Page number 66 is what you want to see, because we will be deploying it on EKS. We'll be creating an EKS cluster, right? So this might help you. So you'll have to download and install the EKS kernel. Down, deploying a multi-node cluster from scratch. I will not, you will have to go through it because if you're doing EKS, you would need it. Setting up kubectl, you already have it. You don't have to worry about it. But still, if you want to go through it, go through it. We've seen this. We've seen describe. We've seen with -o YAML, all of that. Interacting with Kubernetes through web dashboard. Don't worry about this because you have a better UI, which is Lens, right? So you might not need this, but if you want to just play around and deploy a Kubernetes dashboard, it is giving you information about how to do that. So feel free to do that if you want to.
Yeah, Lens is awesome.
Lens is awesome, right? I mean,
Yeah,
even
really nice.
Exactly. So, running your first application on Kubernetes. Yeah, I mean, if you want to, right, this might be a good thing to start with because this is where you'll be able to see. If you go to this YAML file, that is going to be the whole manifest of deploying your dashboard. So even if you don't deploy, at least read through what is there in this manifest. Okay, that will give you some information. Running your first application on Kubernetes, this is where it's going to get interesting. And I think we should start from here, line number 73. So kubectl create whatever image you have created. That's the image that you're saying looks. So I will try to copy this and see if it is already available in Docker Hub so that we don't have to spend time creating those images. I know we are over time. Are you guys okay to continue for a couple more minutes, like 5-10 minutes more?
I'm okay, Samir.
Okay, Samir.
Okay, just 10 minutes because I came in 10 minutes late. Let's cover that up. Yeah. So it's a default namespace, I know. There's something not right with this guy here. Let me get rid of it. So the default is default. Kubectl get deployments because I want to get deployments in the current namespace and it's saying it's this one. So what I'll do is kubectl delete deployment. The name of the deployment is KIADA. Okay, and now if I say kubectl get deployments, it is gone. So what I wanted to do is I wanted to do kubectl create namespace KIADA. I want to create a new namespace, right? Every time we talk about namespace, so let's create it. Now if I do kubectl ns win ls, it should be default still. So what I will do is kubectl
win
set, right?
Yes, set Kayada.
Good. So it is now set to HIDA. Okay, and now if I run that command, which I copied from here, I mean, when we start running this command, right, this is when you'll feel a little excited because it's all fun now. So kubectl get, let's say get pods, okay? I know there's a deployment. So you see there's a pod and it is in the state of 1 to 1. So if I want to do the logs, what is the command?
kubectl logs pod name.
It's working basically. The application is up and running. It's what it's saying. Okay. What I will do is I will show you something fun here. Kubectl get all. What is it? What is there? There's a deployment, there's a replica set, there's a pod. Correct? The desired replicas is 1. You see that, right? What I
Yes.
want to do is I want to do some fun here. I want to do kubectl delete pod and delete this pod. If I delete this pod, what will happen? Can somebody guess?
Yes, one more pod will be created immediately because of the
Okay.
replica set.
So there is no need to specify resource type. Okay, kubectl delete pod. There's already a pod name there. And now if I do all, so you'll see one in terminating. I mean, why is it taking so long? kubectl get pods or get all. You see here, one is terminating, one is running, as how Jyoti said, and that's true. So this guy will get terminated. I don't know why it's taking so long to terminate, but it'll get terminated.
So this is how Kubernetes is ensuring high availability, even though anytime pod is deleted.
Yeah, and
the replica set.
correct. And that is happening only because we have created a deployment. And if you really look at it right now it will become a little easier for you to understand. Romana, I'm answering your question only, but that's troubled me a lot today. Maybe it's getting out of my way. I'm not sure. Let's go to my own world. So when you talk about deployment, right, always get to the concept of peeling the onions. You have a deployment. Inside deployment, you have a replica set. Inside replica set, you have a pod. Deployment uses a replica set to define. So why do we need deployment? We will see it when we look at the manifest, okay? The replica set's responsibility is just to make sure this pod has exact replicas with what we define. In our case, it is 1. So when we destroyed this pod, this controller came into action. It saw that there's a drift. What is a drift? Drift is change from intended state. It saw there's a drift, so it said, okay, you're destroying, fine, but I will go ahead and create new one. So if I really want to destroy everything, technically what I should do is I should destroy the deployment. Let's see if it takes it this way.
Samir, replica set controller is also responsible to read from persistent volume if there is any data available there before creating a new one.
Oh, when you say there's no concept of replica set reading persistent volume, right, Romana? Persistent volumes are tied to the pod, which we've not even seen. Again, I would say park that question because you've not seen persistent volume. But feel free to ask me if you think there's something confusing. Why do you think it is reading? Why do you think
I thought that way? Because now you showed in the diagram, right? So there's a drift in the desired state, and replica controller comes into picture to create one more pod, right? So for duplicating another pod, it should maintain the state, right? So for maintaining the state, it needs to have access to persistent volume. That's how
No. For control plane, the state is etcd. Etcd is the source of truth. Persistent volume is only for your application data. It's the same thing which I said earlier. Everything in the control plane, be it scheduler, be it API server, be it controllers, be it anything, for them, the state is managed in etcd. And all of this, and who talks to etcd? There's only one component that talks to etcd. That is the API server. Anybody who wants to talk to the etcd has to go through API server. They cannot go to etcd directly.
Okay.
And I said earlier, each of the controllers basically listen to change in etcd. So API server put up detail. When we said delete, we sent a command to API server. API server went and updated that detail in etcd. If you really have to look at it, think about it logically. It put that information in etcd that a pod has been deleted and the name of the pod is this.
Mhm.
As soon as that happened,
The replica.
the replica set got activated and it said, oh no, you cannot be doing this because I have been instructed that there has to be at least one pod. And that's the
Right.
reason why it started creating pod,
Right.
right? So here's my advice will be to you guys in general, right? Always think logically. Don't think technologically.
Yeah, that is where I was going one step ahead, Samir. So replica will ensure the pod is created. So within a pod, there should be a container, and the container would have maintained some data, like you said previously, right? It could be a
Mhm.
configuration data or anything.
Yeah, but replica set
we-
doesn't have to worry about that, right, Rumana?
Yes. So who's that guy who will make sure? Okay, you will cover in later topic. I'll I'll park it.
No. Ask that question.
So who is that who will be responsible to maintain the state across the pod's creation?
You tell me the answer. Where is the pod eventually created?
Pod is created inside a node.
No,
Namespace.
I don't know why you are tied to that node. When
Namespace.
you talk about Kubernetes, you should not even talk about node. Actually, never talk about node. A pod would get created by the instruction of kubelet in the container runtime on the node. So you're right there. So I'll repeat it again. The pod will be created on the instruction of kubelet to the container runtime, inside the container runtime, which is Docker engine or whatever, on the node. So even though we do not talk about node, that's what is happening under the hood. Correct?
Yes.
Who is telling it to create the pod? It's the
So-
pod controller.
Okay.
Does pod controller really care about which persistent volume you're tied to, so on and so forth? Possibly yes, because that's a manifest of pod. But my question to you would be, how would that really matter? Because our pods are stateless at the moment. Unless and until you define them as stateful set, they all are stateless. So how does it really matter if there is a PV tied to it or not tied to it?
Yeah, that is where I had my question some time back, right? If you're dealing with a stateless containers or pods, what is the need of persistent volume? And then you said to maintain some configuration data, right? That is where I'm deriving my question from. That if one pod is terminating, and to maintain the desired state, depending on
No,
how long.
you're confusing. You're confusing yourself and probably confusing everybody else. But I still want you to ask the question, is because just now while you were talking, you talked about state, and I'm repeating it again. It is stateless. When I'm talking about state is memory. Persistent volume is data. Now you can ask the question, Romana.
I think I was
Think
this
about it. I mean,
when I started, Samir. So stateless will have no data across pods, right?
stateless
But
will
I
have
got
no
confused.
memory state. Romana, I'm repeating it again. Stateless will have no memory state. If it dies, it can come back again and start serving without knowing what state it was in, no memory. Memory and hard drives are two different things. One is RAM, the other one is hard drive.
Okay.
I'm not discouraging you from asking questions, so please feel satisfied with the answer. If you still have,
when I started this morning, I was clear about state and stateless, but I think confusion came in between when we talked about persistent volume, and I asked, what is the need to have persistent volume with a stateless application? It comes into picture for apps like DB and those
yeah,
kind
but
of
for that,
things.
I think there shouldn't have been confusion, right? Because I answered, and if I'm not wrong, even who was it? Was it Mansa or Jyoti also answered on top of it about config map?
Yes, Samir, it's me, Mansa.
So why is that still a confusion?
And we said, yes, config map is attached to pod.
A pod.
So where is that where is that config map coming from then? Pod
Okay,
is
I think the whole question, Romana, you should park it because we've not looked at config map, we've not looked at persistent volume, we've not looked at secrets. So I would
Okay.
say
Sure.
park this question. This
Yeah,
question is not
let's-
valid right now at this time.
Okay. Okay.
I think
She's
it's fair,
asking,
right?
yeah, yes, Samir, who will take care of attaching that persistent volume to the pod while creating a new pod?
It's a pod controller.
Yeah, I think that's what her question is.
Yeah, but I think I answered that, right? Isn't it?
I got it, Samir. Yeah, let's go on.
All right. Yeah, I would still say park this question because we haven't looked at persistent volumes and config maps and secrets as yet, right? Focus on these areas right now. So what we are talking about is we are talking about deployments, we are talking about replica sets, and we are talking about pods. We talked about if there's a drift, when the pod is deleted, if there's a drift, the replica set is going to come and be see, again, don't take me wrong here. When I say replica set will be responsible to create the pod, nobody creates pod. Neither deployment is creating pod, neither replica set is creating pod, neither pod controller itself is creating pod. It is not. Each one of them is responsible to watch state change in HCD, and based on that state change, put in instruction back into HCD so that when they put that instruction back over here, somebody else who is watching that state could pick it up and move forward. And it's very important for you to understand this. I think, Romana, this should answer the question. When the whole deployment comes in, the deployment controller takes in and separates it up as replica sets and just replica set, basically. It'll put it as, okay, here's the replica set. I know about it. There might be other information over there. It will create and say, I know about this, added it. As soon as it added the replica set controller got activated because that entry was added over here. It looked at it and saw there is one replica for the pod template that it has to create. So there is the pod template that it has to create. So what it did was it took it and it added an entry of pod over here. Okay, as soon as it added the manifest of pod, the pod controller got activated. Pod controllers read through it and said, okay, there's an image that I need. There's a, what is that? Persistent volume that I need. There's a config map that I need. There's a command that needs to be run. It verified everything and it said, okay, perfect. Everything looks good. There's only one thing missing. I do not know which node it has to go to. I do not know. So it would add something inside it and then put it back over here for the scheduler to get kicked out, because scheduler is the one who decides what the node is. Scheduler is going to take this manifest and add the node information over here and put it back into HCD. As soon as it's back into HCD, now there will be something added into that by the scheduler for the API server to pick it up. API server now knows the whole job. It's a delegation job, right? Look at it. Let's make it simple. Let's make it this way. I want to make tea. Tea powder. Who's responsible? Romana is responsible. Water. Samir is responsible. Gas. Saujanya is responsible. Sugar. Jyoti is responsible. Straining, putting up into a pot and giving it to the guest. Let's say Farah is responsible. Okay, so Farah in our case is API server. Farah gets a request that tea needs to be created. Farah takes it and puts it up into a place, or she announces it. Put on the gas. Who's going to be putting on the gas?
Saujanya.
Saujanya will go. The only job that Saujanya does is she will go to the gas and she'll make sure that the gas is turned on. Looks like a cake, but assume it's a gas. Okay. Then as soon as Saujanya says the gas has been turned on, she tells it to who? Farah, right? Farah announces and says, please take water, put it in the pot or whatever, and put it on the gas. Who's responsible? Samir. So Samir comes in and Samir puts a pot over here. Agreed? With water, of course. Samir comes and tells Farah, yes, I put the water on the gas. Done. My job is done. Then Farah says, can somebody please put powder? She doesn't know. Farah doesn't know who is it. She just announces it. And all these guys are watching, right? For the change. Romana comes and puts tea powder in it. Romana says, I've done tea powder. Farah goes and announces, put sugar in it. Jyoti comes and puts sugar in it. And once Jyoti completes the job, Jyoti is going to say, I'm done. Now Farah has nothing more to announce. Farah just has to wait until the boiling point comes up. And then because it is held by Saujanya, she will announce again, turn off the gas. Because Saujanya owns the gas, she'll come and turn off the gas. Done? There might be another guy who would be responsible to pick up this pot and put it up into this, right? The serving one. So there might be somebody, some other controller who's responsible to put it into teacups. There'll be another controller who will be responsible to take it to guest. You're understanding the whole pattern? It's a delegation pattern, right? You're not doing it. Farah is the only one who's giving instructions. And that instructions, basically API server does it, but API server also doesn't do it. It is basically HCD. API server just orchestrates it. Here, Farah is announcing it, correct? That announcement, you can think of it as HCD. I think, well, I should probably just create a recording just for this. I think it's a pretty elegant way to explain how Kubernetes really works. Did you guys understand now, at least?
Yes, sir.
Yeah?
Yes, sir.
Perfect. All right. So the chapter number 20, when you read it, remember me about this whole thing. And this same problem, right? This same solution could be applied to several problems, actually. It's a very nice thing. So imagine there is no one to serve the guest. Now, if you have to create a controller, what is that concept called? If there's nobody to serve the guest and you want to create your own controller that will serve the guest, what is it called?
Custom resource definition.
Yep, that is what it is. So now you understand. Make sense?
Yes,
All
sir.
right. So are we good today? Did you learn anything new?